Chapter 14 is all about energy. Energy has many forms. Even though one form can change into another form, energy cannot be made or destroyed. There are many different forms of energy, and energy has many different meanings. In science, energy is the ability to do work or cause a change. Energy can change an object's motion, color, shape, temperature, or other qualities. You know that some forms of energy, sound, light, electricity, and magnetism. There are other forms too. Chemical energy is found in the bonds holding molecules together. Nuclear energy holds the nucleus of an atom together. Objects that are moving or stretching have mechanical energy. An object that gains thermal energy gets hotter. Here you see electrical energy through the wires. There's magnetism and sound energy in the form of waves. Energy cannot be made or destroyed. We know that from the last chapter and learning about the law of conservation of mass. However, energy can move from one object to another. Energy can also change from one form to another. Consider fireworks. When they are lit, chemical reactions create hot gases. These gases quickly build up inside the fireworks. The fireworks cannot hold the expanding gases, so they explode. Some of the energy in the fireworks changes to light energy and sound energy. Many devices change or transform energy. A lamp changes electrical energy to light energy. Gasoline burns in a car's engine, releasing chemical energy that is used to move the car. Every time energy changes form, some energy is given off as unusable heat. People can measure the amount of any form of energy that moves or changes. These measurements tell which devices are more energy efficient because they use less energy. Again, here are some devices that change energy into different forms. A lamp changes electrical energy into light energy, and the car engine uses gasoline to burn and release chemical energy used to move the car. Kinetic energy. Kinetic energy is energy due to motion. This is going to be very important the rest of this chapter and actually the rest of the year in science. The amount of kinetic energy in a moving object depends on its speed and its mass. The faster an object moves, the more kinetic energy it has. Think about a carpenter using a hammer to drive a nail into wood. When the carpenter swings the hammer slowly, the hammer has a small amount of kinetic energy. It does not have the energy to move a nail very much. But when the carpenter swings the hammer quickly, it has more kinetic energy. It is able to move a nail far into the wood with just one hit. So speed has an effect on kinetic energy. Mass also affects kinetic energy. The more mass an object has, the more kinetic energy it has. For example, rolling a beach ball has kinetic energy. If the ball hits a sandcastle, it might knock down a castle wall. A basketball has more mass than a beach ball. What would happen if a basketball, rolling at the same speed as the beach ball, hit the sandcastle? You would think that the basketball might flatten the whole castle. What would happen if the bowling ball on this page hit the same castle? Make an educated guess. Kinetic energy can change into different forms of energy. A windmill changes the kinetic energy of wind into electric energy. When a drumstick hits a drum, kinetic energy becomes sound energy. Kinetic energy can also change into thermal energy. Thermal energy is heat energy. Right now, rub your hands together and they will get warmer. An increase in thermal energy increases temperature. The friction between your moving hands causes some kinetic energy to change into thermal energy. Potential energy. Potential energy is energy that is not causing any changes now, but could cause changes in the future. Potential energy is sometimes called stored energy. There are several kinds of potential energy. An object may have some kinds of potential energy because of its position. One type of potential energy is gravitational. One type of potential energy is gravitational potential energy. For example, a metal ball hanging from a string is not causing any changes now, but when it falls, it will cause changes to the clay it hits, or the ground it hits. The higher or heavier the ball is, the more it will change the clay. Therefore, the higher or heavier an object is, the more gravitational potential energy it has. When a toy car sits at the top of a track, it has potential energy. The car's potential energy becomes less as it moves to lower positions on the track. The potential energy does not just disappear. This potential energy changes mostly to kinetic energy. As the car speeds up, more energy changes into kinetic energy. A small amount of potential energy changes to sound and thermal energy. There are other types of potential energy. A stretched rubber band or a compressed spring has potential energy. The more a rubber band is stretched, the more potential energy it has. The potential energy of rubber bands and springs can be changed into sound energy. They can also cause the motion of objects to change. When the north poles of two magnets are brought close together and then released, what happens? The magnets move apart. When magnets move, they have kinetic energy. Where did this energy come from? The kinetic energy comes from the changing of a kind of potential energy the magnets have when they are brought close together. In a similar way, two atoms have potential energy when they are slowly brought close to each other. The negative electrons on the outside of the atoms repel each other. The atoms gain kinetic energy when they are released. Another form of energy is chemical energy. A match has the potential to produce light energy and heat energy. The match can do this because it has another kind of potential energy. The potential energy of the match is in the form of chemical energy. Chemical energy is the energy of the electrons that form the bonds between atoms in molecules. That's the definition. Remember that bonds form when electrons are shared by atoms or when electrons are transferred from one atom to another. When more electrons are involved in a bond, more chemical energy is in the bond. When fuel is burned in a car, in a furnace, or a power plant, chemical energy is changed. Heat and light are produced. Different kinds of fuels have different kinds of molecules. This means that some fuels have more energy than others. The fuel for your body is food. Some foods give your body more energy than others. The last type of energy we're going to talk about today is nuclear energy. Nuclear energy is a potential energy that is related to the structure of atoms. All atoms contain tiny particles called protons, neutrons, and electrons, as you know. All of an atom's protons and neutrons are in its nucleus, which is at the center of the atom. Electrons are outside the nucleus. I hope that was a review. So an atom's nucleus contains a huge amount of potential energy. Protons all have the same charge, so they tend to push away from each other. Nuclear energy holds the protons together in the nucleus. Some things can knock a proton out of its nucleus. Then, the nuclear energy that was holding the proton in place is released. So there's where you get nuclear energy. In nuclear power plants, the released nuclear energy heats water until it changes into steam. The steam turns